So we are waiting for more colleges to join. Lecture, I am trying to review the one-phase AC circuits. Actually, this was not part of the syllabus that was given to me, but then I thought instead of directly jumping to the more difficult topics, I'll just first review some of the one-phase AC circuits. You might have already done this subject before, that is, solving the AC circuits. This will be a very good review for you. That's why I'm doing it review. Some of the things I will directly, like if you feel that something is new or something you're not able to understand, feel free to stop me in between and we can all clarify the doubt and move forward. So the way that which I'm going to conduct today is, I have a series of questions already have prepared. So one by one we will see each question, and in the process of solving the question we will be able to understand and review our understanding. Also, one of the most important things for power system analysis course is that we are very much dependent on the calculator, because it's mostly a calculation based kind of course. So the power system analysis itself thinks, you're all the time you're doing some kind of calculation all the time. So you need to have a calculator, and more better will be you need to have a computer with MATLAB or some kind of software like that. So it will be even better, because that can do much more calculations, much more things we can try using a calculator instead of just using a calculator. With computer you can do a little bit more. Okay. Now the thing that I'm going to use is I'll be using one online MATLAB tool that is I'll show that when it comes. So that I'll be using it as a calculator, because since anyway it's an online course and I'm already on computer I'm teaching, so instead of using a handheld calculator I will use the computer calculator, and you can also learn it, and it's very useful and we'll be extensively using it. Okay, so with that brief overview, let's begin the lecture. So I'll go to the first question. Okay, so I'll try to bring it on your screen. So here is the first question. Okay, so this is very basic question. I'll leave the question on the screen. Maybe I'll give you 2 minutes of time. You just read the question and then try to work out the question. So at least up to this part. Okay, so this is there are so many things that need to be calculated. So at least this part, Vmax, Imax, VRMS, IRMS. Whoever is able to answer it, you can answer it through the group chat feature, or you can do it. So I think let's go into group mode, so that at least this part I'm expecting the answers from one of the colleges. Okay.
Evening colleges class.
So Pradeep, we are in group mode now.
Yeah. So
So for the information of the colleges, whenever the presenter is sharing a screen, you can double click on the screen, it can be enlarged. All the colleges are requested to double click on the shared screen so that it will be enlarged. So your student can note down those points on the screen. Madhvi madam.
okay. So now you are able to read by square root of 2. So now you are able to see the values 70.0711 and 14.14. Okay. So these answers I'll put it on the screen. So 70.7 volts, and then this is 14.14 amperes. Now, what is the phase difference between V and I? So, can anybody answer that?
Yes, sir.
So, for finding the phase difference between V and I, you need to know phase of V and phase of I, then you get the difference. Okay. So what is the phase of V? So you just look at the equation. So the standard form, you consider it as sine omega t plus some theta. So this itself is your phase, okay, 30 degrees. So phase of V is 30 degrees. What about I? Let me repeat that. So it is given cos omega t plus 10 degrees. Okay. So first you have to convert it to sine. Okay. So you know that cos theta is nothing but sine 90 plus theta. Okay. So we will use this and then convert this into sine. Okay. That is 20 sine 90 degrees plus omega t plus 10 degrees. So that is 20 sine omega t plus 100 degrees. Okay. So from this, phase of I is nothing but 100 degrees. Okay. So phase of V is 30 degrees and phase of I is 100 degrees. So what is the phase difference between V and I? So phase difference is nothing but, should you do 30 minus 100 or 100 minus 30? So you can do anything. So just you have to mention which one is that one. So here you say 70 degrees is the phase difference. You can say, is the leading or the voltage leading? So you can say current lags voltage. Sorry, current leads the voltage. So because the angle of the current is higher than the angle of the voltage, we can say that the current is leading the voltage and the difference is 70 degrees. Okay, so let's continue. What is the next part of the question? So express V and I in polar form. Okay, so it is very important, it is very fundamental how to express the alternating quantities in different forms. Okay, so I have this equation form, then I have polar form and then the rectangular form. So let's do it in polar form. Polar form. You can also call it Cartesian form. And there is a function in MATLAB that is pole to cart. Okay, so using this function you can convert it. Okay, so I'll show that to you. So I'm going to interface. So here what you can do is we'll be using POL to CART. Okay. I'm just typing the function, so it will display the format, or it will display the help document for that function. So you look at the first one, x comma y equal to pole to cart theta and r. So first you have to mention the angle and then you have to mention the magnitude. Okay. So Vy equal to polar form to Cartesian form. Here the theta should be given in radians. So our angle is in 30 degrees. So 30 divided by 180 multiplied by pi. This will convert the theta into radians. And then the magnitude is 70.7. So here you are getting x component as 61.228 and y component is 35.35. So I'll write down that one. And this angle is 100 degrees. And the angle between V and I is 70 degrees as we have calculated already. Okay. So this is the phasor diagram of the. So with this I have completed the first question. So maybe I'll wait for a while. If you have any doubts about this question, you can ask. Anybody having a doubt, please ask.
ఆల్రెడీ వీడియో వస్తుంది. మీరు మార్నింగ్ 10 లాగిన్ అయ్యి కూర్చొని సెట్టింగ్స్ రమ్మంటే ఏదైనా నేను 1 సార్లు పిలిచాను బిఎస్ఎన్ ఇప్పుడు వచ్చి మన రాష్ట్ర టీమ్ ఎవరు ఉంటారు.
So any doubts about this first question?
టీమ్
Yes, Aditya College. What is your doubt?
Any college can speak now.
Is there any doubt or carry on with the second question? So you are all able to see my screen? I am now displaying the second question on the screen. So you are able to see my screen? Yeah, so anybody having a doubt about the first question you can ask. In the meanwhile, I have just displayed the second question on the screen. Okay, now you are able to see the screen. Okay, so now I am the presenter mode. So if anybody having a question, a doubt about first question, you can ask, or you can also have this question, second question on the screen. So again, I give you 1 minute time for you to review it. Then we'll see it. VBA and find VAB. Okay, so this is your question. So I think I'll go ahead and solve it. So now in the power system notation, if somebody is saying VBA, so what is the meaning? So this is voltage of B with respect to A. Okay? That means if I measure the voltage from A, how much is the voltage of B? Similarly, VAB means voltage of A with respect to B. So for example, you consider a mountain. Okay. So this is a mountain, and this is, let's say, point A, and let's say this is point B. Okay. So this is the, let's say, sea level. So this height is denoted as HA, and this height is denoted as HB. So height from the sea level. HB. Sorry.
The technical person,
This is HB.
faculty na technical person.
So height of A, let's say it is 300 meters, and height of B, let's say it is 200 meters. So what is HAB? So this is height of A with reference height of B. So that will be 300 minus 200, that is 100 meters. Similarly, what is HBA? So this is height of B with reference to height of A. So this is 200 minus 300. So I'll get minus 100 meters. Okay, so like this we can, this is the example of heights example. So similarly, you go to the voltages. In the question 2, I have given VA value and I have given VB value. You have to find what is VBA and what is VAB. So basically you have to do subtraction. So let me go ahead and do that. So what is VAB? So VAB is equal to VA minus VB. That is equal to, what are the values? So 100 angle 30 degrees minus 90 angle 20 degrees. So what is VBA? Is nothing but VB minus VA. So that is nothing but 90 angle 20 degrees minus 100 angle 30 degrees. So I'll write down this one. But in order to do this calculation, again you need to go back to the polar and rectangular notation. So VA, VB, so this is polar notation.
It's small.
100, 30 degrees and 90 angle 20 degrees. So what is the Cartesian rotation representation or rectangular notation? So very quickly we'll calculate that, because for doing addition and subtraction, rectangular form is better, and for doing multiplication and division, polar form is better. So let's convert this 100 angle 30 degrees into rectangular form. So for doing that, I again switch to the calculator.
Uninstall చేసి లింక్ నుంచి మళ్ళీ వీడియో డౌన్లోడ్ చేసి దాన్ని ఇచ్చేయండి. ఇది వేరే
here
లింక్ నుంచి ఫస్ట్ లింక్ అంటే దీన్ని డౌన్లోడ్ చేశారు కదా, చేసిన తర్వాత ఈ కింద క్లిక్ చేశారు కదా.
So Vx comma Vy equal to Cartesian. So the angle was 30 degrees. So 30 by 180 into pi, you have to do that. And then the magnitude was 100 volts. Let me just confirm that. So this is this one. Similarly, VBX, VBY is equal to, in fact, I'll give the name VAX and VAY. Now, VBX and VBY, the angle is, what is the angle for the second one? 20 degrees. So 20, and this one is 90.
హలో,
So I got these values.
ఒకసారి మళ్ళీ ఆ లింక్లోంచి మెయిల్లో ఉన్న ఫస్ట్ లింక్లో డౌన్లోడ్ చేసి దాన్ని ఒక్కదాన్ని ఇన్స్టాల్ చేసి
So these values
ట్యాబ్
I'll
చేయమంటే
write down
చేయగానే
in the
జస్ట్
answer
మీ
sheet.
కాలేజ్ నేమ్ ఒక్కటే అడగాలి. సరేనా? నేను టీమ్
So
లీడర్లోనే ఉంటాను.
86.6 and I'm just sharing my screen again. This is 86.6 plus J 50. This is 84.6 plus J 30 point. It is convenient to subtract. So what is VA minus VB? So just subtract the A minus B. So you get 2.0. And here Pragati Engineering College video is not displaying and video stopped. So from my side I think there's no problem. You are able to hear my audio? Is it okay now? Video and audio?
Yes, sir.
So I'll do the same calculation, but this time I'll use the so minus here and minus here. So I'm getting the magnitude is same, just the angle is become minus negative angle. So that one I'll just minus 1.6715. I'll convert to polar. So into 180 divided by pi. So I'm getting minus 95.7 degrees or 95.8 degrees. So this is minus 95.8 degrees. Okay. So this is the final answer, VAB and VBA. So I hope you understood something from this. So I'll just wait for your doubts. So any doubts on question 2? Or you can also try question 3. Okay, again I'll give you maybe 2-3 minutes time. Read the third question, and if you have answer, you can also suggest the answer. Okay, so again, we got one more correct answer from Aditya College of Engineering Technology. That is correct. What about other colleges? I think it is correct, but needs to be verified. And finally, the third part of the question. Yeah. Okay. So let's check the answers. So I noticed that, okay, so Danekula College also given answer. Somebody from GIST wants to speak, but your voice is not audible. So let's check this. Into 10 to the power of 3 watts into divided by 1000 volts into 0.6. Okay, so these two will cancel each other. So 100 by 0.6, that is 166.67 amperes. Okay, so I got the current. Next is, now I want to find impedance. Okay, so impedance is nothing but voltage by current. So these are all magnitudes I am taking. So voltage magnitude is 1000 and the current magnitude is 166.67, and 1000 divided by 166.67 is 6 ohms. So this is also correct. So what is the next part of the question? Reactive power consumed by the load. So how to get the reactive power? So you might remember there's a power triangle. So this is V into I, this is V into I cos phi, and this is V into I sin phi. Okay. So this is reactive power Q, this is active power P, and this is the apparent power A. So how do you find the apparent power? Apparent power denoted by S actually. So apparent power, so I'll say S equal to, so S equal to V into I. So voltage is 1000 multiplied by current is 166.67. So that is nothing but 166.7 volt amperes. So this is my S. Okay. My P is 100 kilowatts. Is P 100 kilowatts? Yeah. So I think this is, I have to give more zeros. So let me just correct it. 166.67 kilovolt amperes. Okay, I'll express in this one. S is 100 kilowatts. Sorry, P. So from this triangle, I can find out the Q. So what is Q? Q is S square minus P square under root. So that is nothing but 166.67 square minus P square is 100 square, and entirely it is square root. Okay, so let's, to do this calculation, let me go to the calculator and then we'll do the calculation. So I hope you're able to see the calculator. So I'm doing SQRT of 166.67 square minus 100 square. So the answer is 133.34. Okay. So I'll go back to the screen. So 133. So we got the answers from Aditya College and Danikula College. So this is the first answer I got it, and this is the second answer I got it. So all are correct. Okay. So let's move forward. So this is question 3. You have any doubts in question 3? Anybody having any doubts in question 3? You can ask. Or I'll go forward. I'll also display question 4 on your screen. So question 4. So already I have referred to the question 3. Now earlier the power factor was 0.6. Now I want to improve power factor to 0.9. Determine the value and rating of the capacitor to be connected in parallel to the load. So just I have to mention the frequency. So frequency is 50 Hertz. So that you can calculate the value of the capacitor. So can you try now again? Please try question number 4. I'll give you 2 minutes time. Kilowatts. So from these two, I can find what is the apparent power. So AC is nothing but P cos phi. Okay, so you know this from the power triangle. So therefore, from this, P divided by cos phi from the power triangle. So therefore, from this I can find out the S. Okay, so that is 100 divided by 0.9. This is kilovolt amperes. So that I think it will be 111.1 kVA. So once I know S, then what is the next step? So I have to find the Q, reactive power. So Q, so again to remind you, this is the power triangle, and this is 111.1 and this is 100 kilowatt. So P is equal to 100, S equal to this. So what is the Q? So simply we can use it like this, square root of 111.1 square minus 100 square. So this, I know what is the Q. So let's switch to the calculator mode and find what is the Q. So SQRT 111.1 square minus 100 square. So I'm getting 48.4 kVAR. So let me switch back to 0.4 kVAR. Now this is at 0.9 power factor. Okay, so power factor has been improved. So if you refer to question 3, so Q is what? So I just go back to question 3. I got 133.34 kVAR. So 133.4 kVAR, I'll just round it off, kVAR at 0.6 power factor. So therefore, the difference between these two has to come from the capacitor. So if I want to draw the circuit diagram, it will be something like this. So there is a source. Source is supplying to the load. In between, I am connecting a capacitor in parallel to the load. So load is what? 100 kilowatt at 0.6 power factor. But if I view from the source side, it should appear 100 kilowatt at 0.9 power factor. So here what is the power going? Active power is 100 kilowatt and the reactive power is 133.4 kVAR. So but then from the source side, the reactive power coming is only, we just calculated it, 48.4. So the remaining reactive power should be coming from the capacitor. Okay, so that is what is the calculation we have to do. So reactive power from capacitor. So let's do that as QC equal to, so total reactive power is 133.4 minus reactive power coming from the supply is 48.4, sorry. So this difference will be how much? 5, and then 12 minus 4 is 85 kVAR. So 85 kVAR of reactive power is being supplied from the capacitor. So then from that I can find out what is the capacitive reactance. So because I know the voltage also. So what is the voltage? So according to referring to question 3, voltage is 1000 volts. So capacitive reactance, how do you find the capacitive reactance? So you see UC is equal to, let's calculate the current first otherwise. So IC equal to QC by VC. So that is 85 kVAR.
అయితే ఇబ్బంది పడేంత ఏమీ కాదు. ఫస్ట్
1000 volts. So that will be 85 amperes. Okay. So the current is 85 amperes. Now what is the impedance? Impedance is voltage by current. V by IC. That is 1000 divided by 85. So how much is this? 1000 divided by 85. I'm just calculating it. So it is 11.76 ohms. Okay. Now this is nothing but XC. Okay. So what is XC? 1 by 2 pi FC. So here 2 pi f is also known. So I have to just find the C. Okay. So the C will go to the numerator. This will come to the denominator. So C is equal to 1 divided by 2 into pi into 50 into 11.765. Okay. So what is this answer? Let me switch to the calculator mode and show the calculation. So Aditya College has asked one doubt. I'll also address that doubt. But let's complete this calculation and come back. So the calculation is 1 divided by 2 into pi into frequency is 50 into capacity 11.765. So the answer that is coming is 2.7 into 10 power minus 4. Two 2.7 into 10 power minus 4, or if I write it as 270 into 10 power minus 6 farads, okay? Or the answer is 270 microfarads. So if you have a 270 microfarad capacitor connected, it will be able to provide the required reactive power. Okay. So now if I go back, so this answer is not correct. So the correct answer microfarads. So it's okay. It's very normal. Sometimes all the answers need not be correct. So let's go to the doubt. Can't we solve QC equal to kilowatt into tan of phi 1 minus tan of phi 2? Doubts from Aditya College of Engineering Technology. we solve QC equal to P into tan of phi 1 minus tan of phi 2. So is that the question that you are having? So for doing this, you have to know what is phi 1. So how does this formula come? Let me quickly, those who do not understand. So if I consider this triangle, so this is S, this is active power P, and this is reactive power Q, and this is the angle phi. So what is tan phi? Tan phi is nothing but, tan theta is nothing but opposite by adjacent. Or is it adjacent by opposite? Opposite by adjacent. Let me just quickly verify that. Just so what is the opposite side to this? That is Q. And what is the adjacent side to this? Is P. So from this, I'll get tan phi 1 is nothing but Q1 by P1. Tan phi 2 is nothing but Q2 by P2. I'm just writing the subscripts. But P1, P2 is equal in both the cases. Okay. So then what is Q1? Sorry, this is Q1 and this is Q2. So what is Q1? This is P1 into tan phi 1. What is Q2? This is P2 into tan phi 2. Okay. Now I want to get the difference of this. Okay. So Q1 minus Q2. So that is nothing but. So P1, P2 both are equal. So I'll say tan phi 1 minus tan phi 2. So also correct. So if you solve like this, also you will get the correct value of QC. So, but then the problem is what is phi 1 and what is phi 2. So we know the power factor. So we know cos phi 1 is 0.8 and cos phi 2 is 0.9. So let me make some space above. I've run out of space. So I'll just make this space here. And I'll put an arrow from here. So now QC is what? So 100 kilowatt into tan of cos inverse of 0.8 minus tan of cos inverse of 0.9. Okay, so this is what we have to do it. So let's quickly switch to the calculator mode and then we'll solve it. So this is calculator mode. So what is QC? 100,000 tan of, I think A cos of 0.8 minus tan of A cos of 0.9. So let's see what value I'll get it. 26.568. Was that the same value we got? So here I'm getting 85 kVAR. So I think we are here getting some different value. Okay, so I think this is not correct because the S itself is changing. Okay, so the answer I am getting here. So let me switch to this one. 26.52. So not matching. So which one is correct? So what we'll do is, because I think I have one more question I want to solve. What we'll do is we'll keep this here as it is, and then you'll also have time to once again relook at this question. So I have written the question, then I have written my answer. Then there was a doubt from ACET college. Then we also try to work out what is the doubt and what is the solution from that. But then the answers are not matching. So which one is correct? So I don't know. So let's take some time, keep this aside. We'll work it out, and then of course in the next week's class also we can, by the time get the clarity. So we'll verify the answer by next. So is that okay? From ACET college? Oh, okay. I think I just found what is the problem. So the problem is I wrong data I entered. So let me just go back. So it is not 0.8, it is 0.6. So I'll just put 0.6 here. Yeah, now I'm getting 84.9. Now the answer is missing. So I'm sorry. Instead of 0.8, I've entered the wrong data. So 84.9 is. So now it is correct. So let me update it. So this one, I think I have to erase this value. So this is 0.6. So, and the answer that we are getting here is 84.9 kVAR, and then it is matching. Okay. So we can say this one is method 1. And this one is method 2. So method 2. Okay. So we are able, we solve the problem in 2 different methods. Okay. So that's also good. So if you have any doubts, we'll see that. Otherwise, I'll continue with the next question. So I think this is going to be the last question for today's class. So I switch to question number 5. So I had displayed a question number 5, and also in the, for the previous method, previous question, which method is it? Method 1 or method 2? You can also think about that. So I have displayed question number 5 on your screen. So again, take 5 minutes time to and try to work out the answer. This is a little bit once again different introduced. So what you notice is, so when it is without core, the current was more, 25 amperes. But then the moment the core is introduced, the current reduced to 4 amperes. So what is the reason for reduction of this current? So current is reduced because by introducing the core, you are increasing the inductance of the coil, and inductance of the coil is increasing. That means the impedance of the coil is increasing. Therefore, impedance is increasing, current is reducing. And similarly, look at the power. So the power in the first case is 4,000 watts, whereas the power in the second case is only 400 watts. So the power consumed also reduced because of the reduction in the current. So, but then what is asked in the question, you can see the current and power without core and with core are shown in the figures above. Iron losses and copper losses in both the above we have to determine. So I'll wait for 5 minutes. In the meantime, you can work. I hope either question. So what we have here is two circuits. One is without core and one is with core. So let's look at and the object is to find iron loss and copper loss. Okay. So if I write loss in inductor, so there will be two types: iron loss and copper loss. So the copper loss is nothing but I square R. Okay. So iron loss is nothing but heating of core. Okay. So of course this is heating of winding. So both the core will be heated and the winding also will be heated. The reason for winding heating is because the current flowing in a wire will create heat inside the wire. That is the one reason. Now the reason for iron core to heat is because of the changing magnetic field. Okay? Because we are sending AC current. If you look at the circuit above, alternating current is flowing in the coil, and the flux in the core is all the time reversing. So when an AC current flows to the coil, the flux is reversing. Because of that, there is a hysteresis and eddy current losses in the core. So that is considered as core loss. Okay. So how do you represent core loss? Okay. So that is also represented by a resistance R effective. So let's see how it works. So I'll go to the case where there is no core. So voltage is 200, current is 25. So what is the power? So let me try to copy this. So this is without core. I'm just copying the case. So power is 4,000 watts. So what is the current? Current is 25 and power is 4,000 and voltage is 200. So we have everything. First I'll calculate the impedance. Impedance is V by I. So 200 by 25, that is 8 ohms. Next I'll calculate the resistance. Okay. How to calculate the resistance? Nothing but I square R. So P is nothing but I square R. Therefore R is nothing but P by I square. So 4,000 divided by this is R equal to 4,000 divided by 25 square. Okay. So how much is that? I'm just doing it in my calculator. So 4,000 this is 6.4 ohms. So from I know the Z, I know the R. So from that I can find out the XL. XL is nothing but Z square minus R square under root. Okay, so let's do that. I just write it neatly. So 8 square minus 6.4 square under root. So again I am using my calculator, but I am not showing that to you. 8 square minus 6.4 square. So 4.8 is the inductance. So this is J 4.8. So total impedance is 6.4 plus J 4.8 ohms. So this is nothing but 8 ohms the magnitude. You can also calculate the angle for this impedance. So this all is a case where there is no core. Now consider the case where there is a core. So again let me copy the image. So now I am calculating with core. So what is impedance? So the impedance is V by, so 200 voltage was same, but the current reduced to 4. So now the impedance is 50 ohms. So earlier impedance was only 8 ohms. Now suddenly impedance jumped to 50 ohms because of the introduction of the core. As I said, when you introduce a core, it will increase the inductance. Okay, so 50. Now what is the resistance? Again we'll use the same method, P by I square. So this time the power reduced to only 400 watts and the current is 4 amperes. So 4 square. So this is 400 by 4 square. So the answer is 25. But if you notice, earlier the resistance we calculated, it was only 6.4 ohms. Okay? But why we are getting 25 ohms now? So what is happening is, to account for the core losses, the higher resistance is coming to picture. So this is basically effective resistance. Effective resistance of the core is 25 ohms, which is equal to actual resistance plus resistance for iron losses. So this is resistance of copper wire. So this quantity I know. So this is resistance of iron. So this is actually not the electrical resistance of iron. This is just an imaginary resistance of the iron part of the core. So 25 minus what is the copper part of the core? That is, earlier we calculated 6.4 ohms here. So minus 6.4 ohms. So this, how much will I get? Is it 18.6 ohms? Yes. So 18.6 ohms is the resistance that is representing the iron. So what is the iron loss then? Is nothing but I square into R. Okay. So here I will use the R iron. So that is 4 square into 18.6. What is the copper loss? That is I square into R copper. So that is 4 square into 6.4. So these two addition should come 400 watts. That's what is our total loss. Let's check whether we'll get that. 4 square into 18.6. 4 into 18.6. So this one is 297.6 watts. How much is this one? 4 square into 6.4. This one is 102.4 watts. And if you see, if I add these two, it will confirm that total power is 400 watts. So what we learned from it is the total power is 400 watts. Out of the 400, 297.6 is accounting for the loss in the core, and 102.4 is accounting for the loss in the copper. So this is the iron loss and copper. So that is what was asked in the question, and we have answered that question. So I am also getting some answers from different colleges. Very good. So Lingaya's college, they mentioned 5,000 and 6.5, 6.4 and 4.8, which are all correct. And yeah, they have also calculated the angle. Lingaya's college has calculated angle 36.86. So let me write it down. So although that was not required, but here 8 at an angle of 36.86 degrees. So by Lingaya College. So I'm mentioning it in the notes also. And Aditya College has calculated x equal to 43.3. So I am assuming this is the x here. So although it's not required here. See, z we have calculated. Z is 50, and r also 25. So z square minus r square under root, I can calculate the effective reactance also. So x is nothing but z square minus r square under root, and this value is how much? 43.3. So this is J. So this is XL. This is again from Aditya College of Engineering Technology. So what is the importance of this is, you notice that when there is only core and that is without core and with core. So let me draw the core first. So here XL is how much and here XL is how much. So here it is 43.3 J ohms, whereas here what was the XL before? 4.8. Okay, so the coil is same, the wire is the same, winding is the same. Just by introducing a core, the impedance is increased. Not only impedance, the inductance is also increased. Okay. So this is one more interesting thing you can see from this. So Lingaya has also mentioned it is 297.6. So that is also correct. Yeah. So I think this is about the fifth question. Any doubts you are having? So the figure is not given. I'll just draw the figure. This is E1, this is E2, and this is Z. Okay. So E1 equal to 100 at an angle of 0 degrees, E2 is equal to 90 at an angle of 10 degrees, volts and volts, and Z is nothing but J
నేను ఈరోజు పంపిస్తానండి
1 ohm.
బట్ మీ కెమెరా క్వాలిటీ చాలా బాగుంది.
So determine, so I have written above, determine the current in the circuit and active and reactive power. So let's define the current as like this, I flowing in the circuit like this. So this is the current I. So what is I? That is the question. So again, take 5 minutes, you can solve it. This is the last question for us. Oh, I just got a message. There's a next class also. So I'll leave this question with you, so you can work out this question. Everything is there on the screen. You have the question and then you have the answer also. You work out the answer. In the next class on coming Tuesday, I will begin with this question and we'll try to solve it. You have to find. So let's check next week what is the correct answer. So I